Session we were solving question for casting and we had doubt in this question. So actually the answer that I have written from the book was wrong. So the answer for this question will be A will be 4, B will be 6, C will be 5 and D will be 3. So now it is, I think it will be clear. Like in sand casting, we again I have written something. Sorry. A will be 2, B will be 6, C will be 5, and D will be 3. Okay, so firstly, A will be 2. Why? Because in the casting, your solidification will start from the wall. So, finer grains will be at the surface. That is why it will have hardened skin and soft interior. Then second was plaster mold casting is only suitable for non-ferrous metal. Why is that? Two reasons are there. In the plaster mold casting, the maximum working temperature is 1200 degrees Celsius. So mostly ferrous alloys are having higher melting point, right? And second, in this gypsum is present in plaster mold. So gypsum will react with the iron content. That is why plaster mold casting is only suitable for non-ferrous alloy. Then shell mold casting, C5. Uh, so parts which are having a soft skin and hard interior. So why is it happening? Wait, I'll show you. This was our shell molding, right? So how we make, what kind of components we make? This kind of hollow components which are having symmetricity, right? So what happened to make it hollow? What we will do? We will provide one core inside, right? So solidification will start from the core. That is why you will have hard interior and soft skin. Okay. Uh, where is that? Okay, so that is why option C is for 5 and D cut all we have seen like investment casting products will have minimum post casting processing. That means after that all you need to do is do some cutting and you will get your casting. Now today again there are few questions left that we will solve. So try to solve this question. Read first what is it asking, that then try to solve. Anyone got the answer? Okay, let's read this question. A 200 long down sprue has an area of cross section 650 square where the pouring basin meets the down sprue, that is at the beginning of the down sprue. A constant head of molten metal is maintaining by pouring basin. The molten metal flow rate is 6.5 into 10 to the power 5 mm³ per second. Considering the end of down sprue to be open to the atmosphere and acceleration due to gravity is 10 to the power 4 mm per second square. The area of the down sprue in mm square at the end, avoiding aspiration effects, should be. So what is the question actually? This is a part of gating design. This is your pouring basin, and this is your sprue. So what they are doing? They are pouring metal into it. Okay, then uh, there is a constant head of molten metal maintained by the pouring basin. So head will be the constant. Then they have given you one. Firstly, you write all the parameters that is given. This height is given. This height, let's call it height of sprue, HS. Then what else is given? This area is given. Let me call this as A1. And they are asking you this area, A2. Okay.
325 mm,
Sorry.
325 mm, option B.
Option C, ma'am.
Oh, okay. So, okay. So what are the whatever data is given is here. Your A1 is given, your A2 is given. So you have to your A1 is given. They're asking you the A2. So can anyone guess who actually don't have any idea how to solve this question? Can you guess now that what will give you A2 when you know A1? What will give you A2?
Velocity at 2.
Yeah, and Q is given. One thing we know, Q is equals to A1 V1 is equals to A2 V2 continuity, right? So now we know A1, we know A1 here, and if we will get to know the velocities, then we will find the A2, right? So firstly, let's find the V1. Okay, so we can write A1 V1 is equals to 6.5 into 10 to the power 5. So V1 will be 6.5 into 10 to the power 5. Your A1 is given as 650. 650. So this will be 1000, right?
mm per second.
Sorry?
Per second, ma'am.
Yeah, yeah. 1000 mm per second. Okay, just be make sure that all the units you are taking correct. Then now you have V1, you have A1. Now to get V2, here you need to get the velocity. Now can anyone guess what we can do to get the velocity here?
Bernoulli equation.
Bernoulli equation, correct. Okay, you have to make a guess. Firstly, get to know what is happening and what you have to do. Now we will write Bernoulli equation. This is your point 1 and this is your point 2. So for this 2 point, we will write a Bernoulli equation. What is a Bernoulli equation will be here? Simple. Firstly, you write P1 rho g plus V1 square by 2z plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2. Okay. Now, in the question, it is given that aspiration. There is no aspiration effect. Okay, so I have told you what is aspiration effect, right? Can anyone tell now?
Breathing or the pressure inside this will be lower than the atmospheric pressure.
Yeah, when the atmospheric gases can be absorbed in the low pressure areas. Okay, and then it will mix up with the liquid metal and it will form gas effects. So this effect is called aspiration effect. So they are saying that we are avoiding the aspiration effects. That means there will be no low pressure zone throughout the sprout. What does that mean? That means the pressure here and pressure here will be same. And what it will be? Atmospheric pressure. It is mentioned, right, that your down sprue to be open to the atmosphere. So now we know that pressure at P1 will also be atmospheric pressure and pressure at 2 will also be atmospheric pressure, right? And in Bernoulli's equation, what we write? These all are gauge pressure, right? So if some point is at atmospheric pressure, what will be its gauge pressure then? Tell me. In gauge pressure we don't consider atmospheric
Zero.
pressure, right? So it will be also zero and this will also be zero. Okay, now for Z1 and Z2, so consider this height as your Z1, which is HS, and this is as your bottom line. So this your Z2 will be 0. So now you can write it as Z1 plus V1 square by 2G, this will also be 0, is equals to V2 square by 2G. So your Z1 is giving as 200. V1 we have calculated 2. G they are giving as 10 to the power 4. Then V2 we have to calculate 2 into 10 to the power 4. Now solve this. Okay. Tell me what is V2 here? V2 is coming. Whoever got this answer 290.7, please tell me V2.
2236 per second.
Okay, 2236 mm per second. You will get V2 this. So what they are asking? They are asking A2. A2 from where we will get A2? Here. So now we will calculate A2. So your A2 will be Q divided by V2. So your A2 will be 6.5 into 10 to the power 5 divided by 2236. This will come around 290.7 mm square. So your option C is correct. Any doubts in this? Okay, I assume no doubt. Now solve this question then.
Ma'am, none of the option is correct.
Okay.
Ma'am, would it be option D?
Yeah. Okay. So let's read this question again. So volume of a cube of a side L and volume of a sphere of radius R are equal. So we are having one cube and we are having one sphere whose volume is equal. So both the cube and the sphere are solid and of same material. So they are solid and they are of same material and they are being cast. The ratio of the solidification time of the cube to the same of the sphere. So what is given? One sphere is one cube is of side L and one sphere of radius R, which both are having same volume is given. What is asking? The ratio of the solidification time of the cube to the same of the sphere. So it is asking
A, ma'am.
solidification time of, okay, we'll see, Tc divided by solidification time for sphere. So what is first we'll write what is solidification time? Solidification time is directly proportional to V by A square. So I asked you to remember this formula because this is very important. They will ask you so many questions on that. One question for sure. So the volume is equal. So we will both volume for both of them is equal. So we'll focus on surface area. This is surface area. So firstly, surface area for cube will be, what will be? Side is L.
6 L square.
6
And
L square.
6 L square.
Okay, let's write 6L square. And then the surface area of sphere will be whose radius is R. What it will be?
4 pi r
4
square.
4
pi
pi R
R
square.
square. So TC by TS, we can write it as TC by TS will be AS by AC whole square. So volume you can take it as constant because it is equal for both, right? Then we will write 4 pi r square divided by 6L square to whole square. Right. Now in the option, your pi is separate. So we can write it as 4 pi divided by 6 whole square, then r divided by L to the power 4. So which option is matching? Option D is matching. So option D, we got option D, it is correct. Do we have any doubt in this? Okay, I assume no doubts. Now solve this question.
%.
Correct. So what is it asking? While cooling a cubic casting of side undergoes 3%, 4%, 5% volume shrinkage during the liquid stage shrinkage is 3, phase transition or solidification is 4, and solid state is 5. The volume of metal compensated from the riser. So riser is being used for which kind of shrinkage? Liquid state and solidification state. For both we use riser. So 3 plus 4, that will be 7% of shrinkage will be compensated by the riser. So option B is correct. 5% will be compensated by what? Can anyone tell?
Allowance.
Pattern.
Correct. Correct. Okay. Solve this question.
D.
Yeah, D is correct. I think there will no doubts in this, right? Gels we use when we need a progressive solidification or directional solidification. Chaplets we use when there is a critical section or like a section which is having a less low strength. Then we put chaplets on that, like that. Then riser we use for
Reservoir.
reservoir, and then exothermic padding for to support the core. So option D is correct. Okay, now this is again one numerical. Solve this question.
Madam, exothermic padding was for
Exothermic padding is to support. Uh, okay, padding is for control the cooling of critical sections.
Ma'am, here in option D, we have Q matches with 1, but you are saying Q matches with
Yeah, yeah,
3.
I did mistake. I did mistake. Sorry. Solve this question.
Actually, exothermic padding was for controlling.
Yeah, control the cooling of critical sections.
Okay.
Yeah, we put the padding to support the section which is having less strength.
Means it will enhance the cooling.
No, no. Suppose you have some critical section means suppose some section you are casting which is having low strength. So it could go fall off or something like that. So suppose how to make like that some section is there. Suppose this you are making. Okay, this kind of casting you are making. So this will have well like there are chances this is a critical section. There are chances of this will break. So for this we provide paddings. Any critical section which will have less strength. So for that we provide paddings.
Okay.
Solve this question.
Hundred mm.
Yeah, correct. So let's read the question. For the case of molding, it is decided to replace a spherical riser of diameter 100 mm by a cylindrical riser. Determine the size of cylindrical riser that will have the identical solidification time. Assume blind risering and ratio of height to radius of cylinder is 2. So what is it saying? That firstly we had a spherical riser and now we are replacing that riser with the cylindrical risers, and the solidification time should be same. Okay, and then they have given the parameters like the ratio of height to radius of cylinder is 2, and they have given the diameter of riser. So they are asking the diameter for size of cylindrical riser. Okay, so let's firstly write the solidification time is what? T is equals to K B by A square. Right. So let us assume solidification time for your spherical riser is T. So it will be T is equals to K. What will be the volume of the sphere?
Four pi r cube. 4/3 pi r cube.
Yeah. Then what will be the area?
4 pi r square.
So let's write this in terms of D. So when you solve this, the solidification time for the sphere will be K into D by 6 whole square. So from here you can calculate the value for K, right, in terms of T. So your K will be 36. What is your D here? 100, right? 100 whole square into T. So this is one equation, you got the value of K. Then what we actually have to find, let's write equation for cylindrical riser. T, that we have taken small t, so this will also be small t, will be K. What is the volume of a cylinder? Tell me. Pi by
Pi
4,
r.
d square by h, right? Pi r square h. Then what will be the surface area in terms of d? Firstly, it is 2 pi rh. So we'll write 2 pi d by 2 into h plus 2 pi r square will be 2 pi by 4 d square. Correct? Now it is given that h by r is equals to 2. That is h is equals to 2r, h is equals to d. So from here we will cancel dh, d, dh, right? So your final equation will be t is equals to, this will be square, t is equals to k d 2 pi by 4. Pi will also be cancelled, right? Pi, this 2 will be cancelled by this. 2 to 4. When you will solve this, this will also come as d by 6 whole square. So from here you can say, if you put the value of k here, or from the equation you will say that the diameter, whatever the diameter for sphere it was, it will be same for here also. Or you can put the value of k in this equation, then again you will get d as 100 mm. Sure, option A is correct, 10 centimeter. Any doubt in this?
Ma'am, here written blind rising means
Blind risoring means, suppose this is your casting. Here suppose you are putting riser. So risers, this head is open to the atmosphere. So when your riser is filling, you can see, okay, my riser is filled, you can see the molten metal. But blind riser means your top head of the riser is inside the sand. You cannot see if your riser is completely filled or not. So that is what we call blind riser.
मैम इसका आंसर चेंज होता अगर ये ब्लाइंड राइजर ना होता तो?
No. See, but uh, spherical riser, you cannot have blind, you cannot have open atmosphere rising, right? That is why they have given blind rising for both.
Okay.
Okay. So any doubts in this question?
no.
Option A. Solve this question.
A.
Yeah, option is correct. No doubts in this, right? I told you how you remember sprue runner gate. But this is not even necessary. You have to remember how you write a ratio in gating system, sprue runner gate. Okay? Okay. I solve this question.
Madam, sprue base area is minimum area, na?
Sorry.
Sprue base area is minimum area, na?
Where is it written? Okay. Here.
Hi.
Yeah, here it is given as 1. That means it is minimum.
Okay.
They could get you 4 to 1 also. Then what you know here? That your gate area is minimum now. What does that mean? If your gate area is minimum,
Pressurized.
Pressurized bag.
pressurized gating, correct. So the ratio system will be always sprue runner gate. Solve this question.
Ma'am, A.
Yeah, option A is correct. So this is easy, right?
Mhm.
So
Yes.
what is it giving? One cubic casting is giving, whose one side is giving, and it is undergoing to solidification shrinkage and solid contraction of 4% and 6% respectively. No riser is used. Assume uniform cooling in all the direction. The side of cube after solidification and contraction is. Okay, so no riser used means you have to take solidification shrinkage also into the consideration. Okay, so firstly, what will happen here? Firstly, shrinkage due to solidification will happen. So your volume is 50 cube, right? So how much shrinkage is there? 4%. So 50 cube minus 0.04 into 50 cube. This will be your first, firstly after solidification shrinkage, this much volume will be left. Okay, solidification. Shrinkage. After solidification shrinkage, what shrinkage will come into picture? Solid contraction is given. So on this, how much is it coming? This one? Mm, Tell me the size.
12 into 10 power 4.
Tell me in mm. A cube. Okay. Tell me A. How much length is coming now?
49.32.
49.32. Correct. This much mm. Now this is your side. Now after this, what shrinkage will come? Solid contraction will come of 6%. So now your volume is what? Your volume is now 49.32 Q. Q. Then 6 percentage of shrinkage is there. So your A cube will be now point. Why we are putting it? Because volume shrinkage is given, right? So we have to put it on volume shrinkage. 6%, 0.94 into 49.32 whole cube. So let it take as A1 and this is as A2. So what is your A2 coming here? 48.32 mm. Now your option is correct. Any doubt in this? Okay, I assume no doubts. Now solve this question.
1.705.
Okay. Anyone else?
7.70.
Okay. Okay, let's solve this question. What is the question? An aluminium alloy casting is to be produced. You have to make an aluminium casting. A cylindrical hole of 100 diameter and 100 length is made inside the casting using a sand core. The net buoyancy force acting on the core. So we have seen like whenever you need a hole or something, so in your pattern you make a core. Suppose this is your pattern. In this you will fill your casting and you want a cylindrical hole. So what you will do, you will make one core. Okay, now here you will fill the metal and then it will be solidified. Then when you will remove your core and you will remove your pattern, you will get a casting in which there is a cylindrical hole, right? So when your core will be, suppose this is your core, this much hole you want, when your core will be like that, so it will experience a buoyancy force. So we have seen what was the formula for that. So the net buoyancy force that will be act on your core, the formula for that is F net is equals to rho GV, delta rho GV. So V into G to rho M minus rho C. So this is your volume of core. Okay, and this is the rho M is density of molten metal and density of core material. You guys understand the concept of buoyancy, right? So that is how this formula is made. So now we will put the, what is it asking? It is just asking force only. So volume is giving, I guess. Yeah, it is. This one is giving you. Diameter is giving and length is given. So both is given. So what is the volume for a cylinder? That will be pi by 4 d square h. So it is asking in Newton. So we will convert your things in Newton. So it will be zero point 0.1 square into zero point 0.1. Then G is not given, so we will take as 9.81. Density of aluminum alloy, that is your molten metal, as 2600, and density of your casting core is given as 1600. When you will solve this, you will get around 7.7. I got 7.8 newtons. That will be your answer. Any doubt in this? They have given
No,
range
next.
up to 7 to 8. Their range was 7 to 8 newtons. Yes, tell me. Any doubts?
No, man.
Okay. Okay, solve this question. Read the question, you'll get the answer. Just try to read the question, ask, just feel it, what's actually happening here. And then what is it asking and what else, whatever they are asking, the answer will be given in question also. Just try to understand what's happening in the question. then you will be able to solve. Or maybe you're not able to solve, but you'll feel okay. This should I know. What should I learn? Plus 200.
B.
B you said?
Yes,
B.
ma'am. B.
Correct. Just a second. क्या बोल रही है? अभी टाइम लगेगा. हाँ. Sorry.
D.
Yeah, B is correct answer. So again, we'll read the question. What is it asking? The solidification time of a casting is proportional to V by A square. We also know that. V is the volume of the casting and A is the total casting surface area lost to heat. Okay, we also know that. Two cubes of same material and size are cast using sand casting process. Okay, the top face of one of the cube is completely insulated. The ratio of the solidification time for the cube with top face insulated to that of the other cube. So everything is given only. So in this, what is ours? They already told that your casting surface area, whichever is in the whichever is losing the heat, that area only you have to take in this formula. Like T is directly proportional to V by A whole square. V will be the volume of your casting, and A will be only that area, only that surface area which is losing heat. So what they did in one of the cube, they completely insulated. That means there will be no heat dissipation from that phase. So in just you have to you will neglect one phase to solve this question. Okay. So so it is simple, right? So T1 by T2 volume is same only, so let's not consider volume. Will be A2 by A1 square. So suppose your A2, the ratio of the solidification time with the okay. So your T1 will be having 5 faces only. Its area will be 5A square, and area for T2 cube is 6A square. Okay, 2 whole square.
It means the volume is not affected, only this one of the side is changed.
No, no. See, your heat dissipation is from volume. Only your dissipation is depend upon the surface area which is in the which is losing the heat.
Okay.
So your T1 by T2 will be 36 divided by 25. Option B is correct.
So solidification time depends on the area of contact and not on the volume.
See, volume you should remember like that, that V in the V by A whole square, volume is the whole volume of the casting. Okay, it's not for the molten metal, it's the volume of the casting, and the area is the casting surface which is losing heat only. Uh,
मैम आई वांट टू आस्क अ क्वेश्चन मैम. मैम इन द केस ऑफ राइजर, जो बॉटम सरफेस होता है उसमें तो जो राइजर का बॉटम सरफेस है उससे तो हीट लूज होगा नहीं, क्योंकि वो कांटेक्ट में है मोल्टन मेटल के पहले से जो कास्टिंग में है, तो उस सरफेस को कंसिडर हमें करना ही नहीं चाहिए.
wait. This is your riser. Suppose this is your casting. Two types. This is your top riser means. You are saying that this is in the contact of
Molten metal at the same temperature. So
see, whenever they give question, they will tell you. They will tell you if it is in contact of molten metal or not. So none of the questions they have mentioned like that, right? They are just asking there is one riser, and they are not telling you not to consider this side. only take it if they have given in that.
मैम मैं मतलब प्रॉब्लम के पर्सपेक्टिव से नहीं, मतलब मैं थ्योरी के पर्सपेक्टिव से पूछ रहा था कि तो इसके को कंसिडर करना चाहिए क्या बॉटम सरफेस को?
See, firstly, riser is connected with the metal casting, right? They both are connected. So when you're designing it, you're designing in such a way that this will be solidified first and this will be solidified last, right? After this will be solidified. So if you're taking its solidification into consideration, so you may feel like after a solidification of your casting it started solidifying, right? So this is already solidifying, so you will now this surface will also lose the heat, right? Now it is not working as a heating chamber, right? So this will also lose heat now, so you will consider this part also. You understood my point?
मैम बट ड्यूरिंग द सॉलिडिफिकेशन फेज ऑफ द
Hmm.
कास्टिंग उस वक्त तो उसका कोई रोल था नहीं,
Riser का
राइजर के बॉटम सरफेस के हीट लूज करने को, बिकॉज जो सॉलिडिफिकेशन हो रहा है कांस्टेंट टेम्परेचर पे ही अज्यूम करके चलते हैं.
हाँ सी क्वेश्चन में क्या बोलता है कि राइजर का सॉलिडिफिकेशन टाइम पूछेगा तुमसे, राइट? तो यू आर आस्किंग कि when this part is into contact of molten metal, so we should ignore this part, right?
हाँ मैम यही पूछ.
हाँ. So what is actually happening? We designed our riser in such a way that this your metal casting will solidify. After that, your riser will start getting solidified, right? So now tell me whose temperature will be higher? Your casting's temperature will be higher or your riser? Here solidification will already happen. Now it's time to your riser to get solidified, right? So this will have at low temperature, this will have at high temperature. So on this surface, at surface what you are asking that we should ignore, there will be heat transfer, right?
ओके मैम, ओके
We
मैम,
cannot ignore that, right?
यस मैम, समझ में आ गया.
Okay.
मैडम इस जब तक क्वेश्चन में अलग से दिया नहीं होता तब तक हम दोनों सरफेस से हीट रिजेक्ट लेंगे.
हाँ, क्योंकि एक्चुअल में वही होता ही है. If it is not giving, suppose it is saying that your riser and your what is this casting is both are getting solidified at the same time or something like that, which is not practical, then only you have to take. Baki, whatever is actually happening, understand that why riser is there. It will get when it will get solidified, how the heat transfer is happening. Just think about it. You'll get the answer.
ओके.
Okay. No doubts in this question, right? For this question? Now you can see how many questions on the solidification, only one formula itself. We have solved like 4 or 5 questions on this formula till now. One more question is on that. So practice as many as question possible on this formula. That will clear your concepts.
नाइन पॉइंट नाइन टू फाइव.
Okay. Anyone else?
Six point two.
Yeah. 6.2 is correct. I hope you all are using gate calculators while solving the questions, because it is, if you're not using it, start practicing on gate calculators. So let's read the question. A cube and a sphere made of cast iron, each of volume 1000 centimeter cube, were cast under identical conditions. The time taken for solidifying the cube was 4 seconds. The solidification time for the sphere is. So all the game is with the area. So T sphere and T cube, because the volume is same, we'll write it as AC divided by A sphere, A cube divided by A sphere whole square. So what is the area for cube? 6 A square, right? A is given? No. 6 A square. Notice the area for sphere, 4 pi R square whole square. Oh, one more thing is given, volume is same. So V sphere will be V cube. Your V cube is A cube, that is 1000. So your A
10.
value will be
10.
10.
And our value would be 6.2035.
Thank you. R is 6.20 centimeter. Now we'll put the values here. Will be 6 into 10 square divided by 4 pi into 6.2 square whole square. Then she said answer is 6.2 second or 6.15 second. That I got. Okay. Any doubt in this?
I mean, these questions range will be wide. No?
Sorry? Range, yeah. And that range it depends on them. Sometimes they give very sharp range. Like your answer should be in between 6.15 to 6.2 or more sharper than you say 20. So this is very sharp range, right? So your answer should lie in between, otherwise they will take it as wrong. That system will take it as wrong. So whatever, try to get correct answer and fill that answer. Any doubt in this? Okay. Solve this question. Should again solidification time only.
Point two five.
Okay. He's got 0.21.
0.25.
0.25. Anyone else?
0.5625.
0.5625. Okay, 0.5625 is correct. So same question only. T cylinder is K P by A square. Then what is it saying? Solidification time of a cylinder casting. H is equals to R, and to that of a cubic casting. So you have to find T cylinder divided by T cubic of a cubic casting of side 2 times of the height. So your A will be 2H. That will be 2R. Okay. That is D. So A is D. Okay. Now we will put the values. T cylinder K, your volume will be pi r square into h divided by 2 pi r square plus 2 pi r h whole square. H is equals to r. H is equals to r. So we can write it as T cylinder is equals to K. It will come as cancel. Okay. I have solved it. It is coming as r square divided by 16. Now the same way you'll solve for Q. K V by A square. It will be K A cube divided by 6A square whole square. When you will solve this, it will come as T cube is equals to K divided by 4R square divided by 36 in the terms of R. Both you should get in the terms of R, and it will be R square divided by 60 to R square divided by 9. So at the end it will be 9 by 60. It will come as 0.5625. Any doubt in this? Okay, I assume no doubts. Solve this question. Shape factor.
What is shape factor?
Shape factor, I have, if you don't remember the formula, this is formula for the shape factor. See, you guys might have this term in heat transfer, that the radiation depends on the shape factor, right? The same concept is utilizing here also. The shape factor, uh, like uh, the shape factor is being utilized in the uh, designing of your riser. So this is the formula. It is denoted by Z. Z is equals to L plus W by T. Now I have given you this formula. By use of this formula, read the question and try to solve it.
3 centimeter.
Okay.
LWT length, width, and thickness.
Yeah. Tell me what is that? With your for your dimension of for your riser, what is that?
Shape factor L plus W by T. 25 plus 15 by 5.
Yes. Eight, right?
Yeah.
Now you know how to solve it. Now tell me for shape factor of 8, they are giving riser volume divided by casting volume. What is it asking? Diameter of the riser. And what is given? Height and is equals to diameter. So now you know 0.5 is equals to riser volume. What will be the riser volume? Casting volume is given. What will be the riser volume? Pi by 4 d square h. Let's write it like that. Pi by 4 d square h. When height and diameter is equal, we can write pi by 4 d cube. Okay. Casting volume is what? 25 into 15 into 5. They are asking the value of d in centimeter. So it will be 0.5, 25 into 15 into 5 into 4 divided by pi raised to the power 1 by 3 is equals to d. So solve this. D is coming as
10.61.
10.60 centimeters. I'll tell you more about shape factor in the next session maybe. Any doubt in this? Apart from the shape factor, that why it is here?
No, ma'am.
Okay. This question we solved in next last session. Solve this question. Try to draw first, and
Ma'am,
yes.
should we apply Bernoulli's equation like
Sorry.
to, ap- to approach this problem? Should we apply the Bernoulli's equation?
No, you don't need to. I guess.
Is it 2 meter per second?
Yeah, it's almost two. Good.
2.042.
Yeah, good. We don't need Bernoulli here, right? See, let's make the diagram. This is your basin, then the sprue. When we use Bernoulli, can anyone tell me? Let's take it as H1, this one H2, this is H total. So a sprue in a sand mold has a top diameter of 20 mm. Okay, so diameter at this, let's say this point at point 2, D2 is given as 20 mm and height of 200 mm. So this height H2 is also given as 200 mm. The velocity of molten metal at the entry of sprue, that means U2. U2 is given as 0.5 meter per second. Assume G as 9.8 and neglect all the losses. If the mold is well ventilated, the velocity of molten metal at the bottom of the sprue is.
So here do we need H1 actually?
Sorry?
Here actually do we need the height of the pouring basin?
Yeah, we need height of the pouring basin. See what is given? Velocity at U2 is given. How we will calculate velocity? Suppose some height is given. So due to that height, what is the velocity of fluid? What is the formula?
Root 2 GH.
Now your U2 will be root 2 GH1, right? See, you may need total height to get the velocity here. So for that you need to get basin's height. So that's how you will calculate basin's height. Okay, so we will write it as what is H1 coming here? Tell me.
Four point seven four mm.
4 point.
12.7.
Tell me, you have taken units right? It is in meter per second. It is 0.5. So tell me in meter itself, what is H1?
0.012.
Right. 0.012 meter. Now your H total is H1 plus H2. Then it will be 0.12 plus zero point 0.2, it will be 0.212. Then your U3 will be under root 2DHT, it will be 2 into 9.81 into 0.2127. So it is coming as 2, right? 2 point something 0 meter per second.
We can use Bernoulli's equation to solve this, na?
Yeah, we can do that also.
And here they have mentioned mold is well ventilated, means P1 and P2 atmospheric.
Uh, See, P1, P2, when their aspiration, they have mentioned that it is atmospheric. So mostly we designed it like that. We assume what are the main works of sprue is to maintain the atmospheric pressure here and here also for less losses, which is not actually practical, but we assume. So every time if they have not given any particular pressure, that pressure is getting lower in between here or there and like that, always consider, always take pressure as atmospheric pressure. That means gauge pressure will be zero in your Bernoulli's equation. Okay.
Okay.
So how it will come in Bernoulli's equation? Can you give an idea?
Sorry.
Using Bernoulli's equation, how will we get it? Can you give an idea?
Yeah, same only, same equation. Now at the place of Z, you have to put HT.
So in that case, we don't need the area of the entry.
Yes. This is yeah, yeah, correct. Okay, any other doubt in this?
No, ma'am.
Okay, assume no doubts. Tell me the answer of this question.
Fine.
C.
Okay. Someone said C. Any other answer anyone said before that? I'm sorry, I couldn't hear you.
No, I just said fine.
Okay, fine. Fine is confirmed. Fine, we know. Now it is a randomly oriented or ordered that we don't know, right? So everyone feels it C.
Ma'am,
I think it's B.
Yeah,
randomly oriented.
B, madam.
yeah. B is correct actually.
Why, ma'am?
Okay. Let me tell you little. This will be little higher level, but try to understand. Okay. Suppose there in one casted alloy. So suppose one casted ingot is there. Okay. So when you will roll it, when you will roll this sheet, suppose in this direction you are rolling. You know rolling, right? Simple rolling. You are putting compression force and your ingot is getting rolled. You know rolling, right?
Yes, ma'am.
When you are rolling it, so after rolling there will one texture form. Okay, what does that mean? That all the grains will be oriented in the same direction. Suppose this is a grain. Okay. In the grain, the crystal will be oriented. The crystal will have some orientation. Okay. Suppose this is your crystal. It will have this orientation. Then another grain is there. Why different grains are forming? This grain will have some different orientation in this crystal are oriented like that. So only if any kind of deformation is happened, after deformation, all the grains will be oriented in that deforming direction, ruling direction. But when the solidification is being happened, your grains will be formed as oriented. It will be ordered only when it is a deformed structure. Did you
मैम
understand?
ग्रेन का
Yes.
मैम ग्रेन का ओरिएंटेशन और क्रिस्टल लैटिस का ओरिएंटेशन दोनों एक ही बात है?
See, this is a grain. No, no, no. In the grain, how your how your crystal is oriented, that is the orientation.
तो मैम क्रिस्टल के ओरिएंटेशन को रूलिंग फिक्स करता है या फिर ग्रेन के?
Crystal orientation. Suppose grain is what? There is a solidification started here. Solidification started here. So the why is it, why there is a grain boundary? Because the orientation inside the grain of crystal is different. That is why there is a boundary, right? In this, whatever the how many crystals will be have, they will all have same orientation. Here, whatever crystal will have, they will have same orientation, but they will not. There will be orientation difference between two grains. That is how grain is forming, right?
यस
See,
मैम।
suppose one metal is there. Suppose it is a BCC crystal structure. Okay, and then grain boundaries are there. So all the grains will be made of crystal, right? The grains will be made of crystal. So in this boundary, all the how boundary decided that orientation of the crystal. So all the crystal in this grain will be oriented in single direction. All the crystal in this grain will be oriented in single direction. Suppose you perform some deformation, rolling or something, then your all mostly, not all you can say, most of them will be having same orientation. Okay, so that is why your option B will be correct. Fine and randomly oriented.
ओके मैम।
Okay. Okay. Solve this question. Okay, I'll take a screenshot of this question and try to solve on your. This is also solidification based only. Solidification time. You have taken?
Yes, ma'am. Yes.
Okay. Tell me answer of this question. We have already done this. No, no. Tell me the answer of this question.
Screw.
बी।
Correct. Okay. Solve this question. Take your time. Solve this question. Write the data. Try to get what is it asking. Okay, let's read the question. So operation is what? Centrifugal casting. So what we learned about centrifugal casting, there will be one cylinder which will be having a rotational motion, and we will fill the molten metal inside the motion. and because of centrifugal force, the molten metal will be thrown out towards the periphery, and that's how casting will be done. What we make tube, big tubes with the help of this casting. So centrifugal casting operation needs to be performed horizontally to make a copper tube section that we know with the outer diameter of 250 mm. So D outer is 250 mm and D inner is also given as 230 mm. G is 10. If a G factor, so what is G factor? We don't know what is a G factor. They made this term on their own, which is what? Ratio of centrifugal force to weight. What is ratio? Fc divided by weight. W is what? G factor. They are calling it as G factor. Then, which is 60, is used for casting the tube. The rotational speed required is what they are asking. What do we know? Omega.
Ma'am, is the answer 675?
675. Wait, let me check. It's around 660.
Okay.
661 or so. Okay, we'll check. Okay. So now you have Fc divided by weight. I'm writing it as mg as 60. And they're asking omega. So from where we will find omega? Which term will contain omega? Centrifugal force we know is mr omega square.
MR omega
So
square, yeah.
mr omega square divided by mg is equals to 60 given. R is also given. R which one? R which R we will take? Outer, right? Outer diameter. So and omega we can write it as 2 pi n divided by 60 whole square. This is R naught divided by G is given as 10 is equals to 60. So we have space. Okay. Now it will be n is equals to root 2 into 60 into 10 divided by d naught. I have written R as d naught by 2 into 60 divided by 2 pi. So your n will be 662 rpm or 661. Does anyone match my answer?
Yes, ma'am. 661.5946 ऐसा कुछ आ रहा है.
Okay, around 662, 661, that will be your answer. Any doubt in this question?
No.
How did we decide the outer diameter?
See, force itself. What is centrifugal force? It is for the outer diameter, right? Whatever will be touch here, this will be rotate. There will be a rotational motion, right? So when you take the centrifugal force, you take the outermost surface diameter, right? Suppose this is rotating around its axis. So how will you calculate? The G, okay, let me tell you this way. The G will be working for the whole weight, right?
Ma'am,
Yes.
sorry for interrupting. Ma'am. One thing is, it is also mentioned that horizontal centrifugal casting. So therefore, which will be touch the horizon. So in that concept.
Sorry.
Actually, as it is mentioned that horizontal centrifugal casting, so outer radius would be touch the.
Yeah. That is also that is the best explanation. Okay, you understood?
Actually, if it is a ring, usually itself we take the outer radius only. Like with an outer and an inner diameter, then the centrifugal force on this will be considered with the outer.
Okay, tell me what is the difference between outer and inner here? How much difference?
I think 10 mm.
Yeah. So will be a look that will look like a ring, right? The cross section.
Yes.
So that is why we are taking outer.
Yes, that's what I was like for usually for a ring when we take centrifugal it will be the outer radius is it I'm asking.
We always take outer itself for when if it's in the case of horizontal.
Okay.
Okay.
If it is vertical, then ma'am.
Vertical, same only, outer only you will take. But one more thing will come into picture. What it will be? Can anyone tell?
Accumulation at the bottom.
Okay, you're talking about casting, centrifugal casting in vertical.
हाँ मैम जी मैम.
I thought you were asking about.
Gravity force.
I have never seen centrifugal casting as a vertical.
No, but still, is it the vertical force which is coming?
Yes, I cannot tell
Sorry,
about the
gravity.
centrifugal casting as a vertical to be performed. I'll check if it is there or not. If some term is there, vertical centrifugal casting or not. Okay, we'll
Madam,
discuss. Tell me.
but if we consider horizontal casting, then we know Fc is equal to mr omega square. So for safety purpose, we will take r. We should take r of inner radius for safety. Otherwise, that material would not have that much centrifugal force.
This is not something that we can take, right? What is the centrifugal force? This is force which is generated on its own. Now we are not taking it, right? This is a pseudo force, right? You understand the concept of this, right?
Yes.
So it is a concept itself. You have to take out it. Okay, we will discuss this later also. Let me write doubt on this question. We will discuss in next session again. Okay, I'll go through it again. Numerical wise, you are okay with, right?
Yes.
Okay.
Yes ma'am.
Okay. Concept we'll see again. Uh, this is again a solidification based question. Take a screenshot of this question and solve on your own. Same only. You have taken?
Yes ma'am.